Okay, yeah, we're in business. Awesome. Thank you, folks. Thank you for your patience. Thank you, Matt, Molly, and Jacob for your patience. I think we'll just let you get started from here.
All right. I think the demo gods are with us now. Okay, so we gave our introductions, so I think we'll just skip past that. Jacob, you want to start in with some of the history and why we're here?
Yeah, absolutely. So this is both a project that's been fun to work on and a passion project for a couple of years, but this year's been different. And so this year we launched a State of the Edge report, which we've done now 3 times, but the 2021 report is the first one that we've done under the auspices of the Linux Foundation. So we'll tell you more about that, but essentially we moved into the LF Edge organization at the Linux Foundation and have been kind of continuing our work that we started a few years ago, but with a much broader community and more participation and all kinds of benefits really of being within an industry group that's leading the conversation around edge computing from a business perspective and a technology perspective. So we just launched it. It's free to download, so you're more than welcome to go grab it. The report will talk through the highlights, but we're not going to read it for you. So if you would like to check it out, I think you'll find a lot of interesting things in it. We'll point you there later, but go to thestateoftheedge.com for this year's report and also the previous reports, which we've done, and give a kind of sense of where we're coming from and where we've been. One of the important things, and we'll get this as you go throughout, is that this is intended to be a vendor neutral report. So while we all have day jobs, which we mentioned when we were introducing ourselves, the work in the report is neutral, and it's meant to be a look at the industry and a look at the ecosystem and a look at the technology without a perspective of one particular company. So hopefully that comes across. And I think that's been one of the strengths of the project over the years, is that it's been different companies who often compete with each other, but really trying to advance the ecosystem together. Okay. So a little bit of background, and then I'm going to ask Matt to do the fill in the blanks where I get off the reservation. But essentially, we started the project a couple years ago in 2017 with the idea of how do we bring together the ecosystem around essentially a common definition of edge. That was the first impetus for us. Like, can we all just agree? There's a lot of marketing words going around. We know, because we're all marketing people. So we probably didn't, we weren't blameless in that situation. But the idea of how to move together towards the opportunity of edge computing, with a common understanding of what is the edge and how do we understand what's happening, was the initial impetus for starting the State of the Edge back in 2017. So we put out a couple annual reports and then one topical report around data at the edge. And they've been just really wildly successful in terms of number of people who've downloaded them and started to adopt some of the key components that we'll talk about today, like the glossary for edge computing and also the landscape project. So Matt, do you want to do the LF Edge structure and how we fit in?
Yeah, sure. So the Linux Foundation has what they call these umbrella groups, and the CNCF is probably the most well-known, the Cloud Native Computing Foundation, which is the home of the Kubernetes project, among others. And LF Edge is a more recent one. It was founded last year, and we were one of the founding projects. So as Jacob mentioned, we started the State of Edge as a sort of a separate quasi-entity, and then we conveyed all of the assets to the Linux Foundation. So it's a complete open source based project, community based project. A lot of the assets are stored in GitHub repos. The research is all freely available under a Creative Commons license. So there are a number of projects at the Linux Foundation in the LF Edge umbrella. Most of them are actually code-based projects, open source projects. So I'm sure you've heard of like Akrano and EdgeX Foundry, which are probably the two most popular. But there's a number of projects that are in different stages of growth, and you can find all of that at the lfedge.org website.
Cool. And it's been a long year, but April 8th, 2020, almost like exactly 1 year ago. Good timing. So that was when we came over. Okay, great. So you can go ahead and get a sense of this on LF Edge. I encourage you to check out all the other projects. As Matt said, we're the least technically interesting of the projects, but we really have kind of found our groove in terms of bringing bringing shared understanding, also bringing out trends, and not all of them are what everyone agree on, but I think we've really cast the net pretty wide, especially this year, to a lot of different parts of the industry, which is honestly in really good shape. It's been a really awesome year to look at the Edge ecosystem. So there's a couple components that kind of represent our work: the research and publication, which is the part that I led this year, the Edge landscape, which Molly will talk about, the open glossary of edge computing, which Matt will fill you in on because he is all about the edge computing glossary, and the edge taxonomy. Okay, great.
All right, let's dig into this.
Let's do it. Let's dig into the report. Okay. So the first thing is that this was a community effort. So you got some pictures on here, mainly because we had a core group of people who were involved in bringing together the research, deciding what we were going to do, recruiting the authors that you see up the top row here, and then helping to bring the report to fruition. So it's a community effort. No one, directed it from anything other than their interest and their passion. We were really fortunate to recruit a great editor. So Charlie Ashton was our editor, pulled it together, and really did a great job. So if it reads like one voice, although it was written by many, we can thank Charlie. We also asked 4 different experts to help us, and the reason was as we came together as a group, we were really trying to find out what was interesting this year, right? And what's valuable. And we came to a few different topic areas, and we're going to cover them in a little bit, but basically hardware, software, networks and networking, and critical infrastructure. And so we asked a different author to help us give their perspective and really bring a research mindset to each one of those. So Simon Bisson, Mary Branscombe, Phil Shee out of Toronto, and Phil Marshall helped us with those. Phil Marshall also continued some work he started last year with us, which we'll go into a little bit of depth on, which was an overall bottoms-up model, kind of forecasting the market size of edge computing, which is, by the way, big number, $800 billion, really nice. And so Phil did an update for that as well. So we had 4+1 there. And it was a team effort. We did it over the course of about 4 months. So 3.5 months of work led to the report that you can download today. Cool. Okay, so let's go through each of these. We're going to go through and give you the highlights, but essentially, we really thought that the market size and growth was probably the most interesting from the outward perspective. Like, what's the business opportunity and how has it changed? And so we had a unique opportunity to do that because of the research that we published last year. The 2020 report was dedicated to this forecast that we had produced with Phil Marshall. So updating that was top of mind. Critical infrastructure is, and we'll come to each of these in turn, but is often, I think, seen as one of the earliest parts of investment in the edge ecosystem, because you have to have a place to put stuff. And so, the data centers, the towers, the connectivity, has been a real focus of our research over the last few years. And so we continued on that. I love that this is the IoT and that meetup, and that there is a, I think that Hans, you mentioned earlier, you had started a collaboration with the university around hardware innovation and hardware-based startups, which is just a fascinating thing, especially at the edge. So super cool to see that, and I love this part in particular. Like, there's so much cool stuff happening, and maybe you can add to that later too, because I'd love to hear how you're seeing the startup ecosystem around hardware kind of blossom, which I think we saw some signs of as well. Cool. Everyone talks about the edge, about latency, and so nothing works without networks and networking. And this really looked at a few different technologies, which we'll go into, but especially is interesting in the kind of shifting and evolving nature of the internet. Right? And so the edge of the internet has always been seen at a pretty much where the interconnection points are, and that's been pretty regional. And so we looked into that, thinking about the different ecosystems that are evolving there, and then the technologies that are driving them. And then finally, software, which is like, I was going to put up a poll later. We might have to do it because it looks like a button here about, hardware or software. It's like, decaf or regular. And what we see at the edge is so much of this goes together. That hardware and software and networks and critical infrastructure all have to go together in order to make the reality of the edge work. Great, Matt. Let's move on.
Okay. So I'm going to cover the market model, and let me give a little history of this. So last year's report, the 2020 State of the Edge report, is entirely dedicated to assessing the market and the elements of the model. The model itself, Phil Marshall from Tulaga Research created. He's ex-Yankee Group. This is one of the most complex Excel spreadsheets I've ever seen in my life, and you'll see how sophisticated his model is. But it is just a model. So we know one thing about it, and that it is wrong, and we don't know which direction it's wrong. So we put it forth not as the absolute answer to anything, but as a way to have a conversation around a really interesting topic that potentially affects us all from a business perspective. One thing I will say, and this sort of reflects the bias of the origins of the State of the Edge, and that it is very data centric, data center centric, and infrastructure centric. So we studied pretty much everything that is not a device, which is probably the least interesting thing to the people who in the IoT group are probably mostly focused on devices. That was a very conscious decision back when we did the original model. And at some point, I'd like us to update the model to cover the entirety of edge computing. Although there's a really interesting question here, because at that point, the edge just becomes the internet. And in fact, that's sort of our whole thesis in many ways, is that there is no one edge, and it really certainly starts to blur when we have continuously connected networks and tremendous amount of compute, not just in data centers, but actually on the devices themselves. A Tesla's got 6 or 7 servers in it. So I think it's really an interesting and dynamic world. But so one of the things that we did, as Jacob said, in the very first version of the State of the Edge report, the 2018 report, was we tried to put some definitions around this. And what we decided is, look, there's lots of edges. We actually asked people. I got some really interesting answers. Somebody said, the edge is the wall of my data center. The edge is the cell tower. The edge is the bumper of my car. That's my favorite, the edge is the bumper of my car. And so we said, look, the most important thing is, what's the edge we care about? And we felt as an industry, the edge that was most important was the edge of the last mile network, because that's where the digital world meets the physical world. And there's 2 sides to the last mile. There's the device side and the infrastructure side. The Linux Foundation, when we merged with them, we had a whole exercise. There's a really wonderful white paper that's on the LF Edge website that talks about the different elements of the edge from the LF Edge perspective. But one of the things we did is we harmonized some of these definitions. So in the Linux Foundation vernacular, the device edge is actually called the user edge, and the infrastructure edge is called the service provider edge. We maintained in these slides the terminology that we used in the original model, but just so if you're trying to compare and contrast with the terminology in the Linux Foundation, that's the difference. And what we did is we paid attention to what workloads did we predict would be running based on the use cases that were predicted to be available, and the kinds of compute that those use cases would demand, and where that compute, again, from a server perspective, would primarily be located. And the use case categories we studied across, I think it's 11 categories. And in each of those categories, there were subcategories, and it's everything from the core infrastructure. So how are these 5G networks going to run? That's edge computing. It requires servers at the edge because the network functions are virtualized. You've got a lot of support for mobile devices, consumer devices, gaming, information services, health services, that sort of thing, residential, retail, healthcare, energy, all of these. And Phil looked at all of these, and he looked at them from a worldwide, global basis, and again, built up this concept of, okay, what are the use case categories? What are the growth in predicted growth in those? What are the macroeconomic factors on a global basis and a country by country basis? And then where do we predict those workloads will be, and what migration trends do we see, right? Do we predict a migration from a workload on the device to a server. So if today you're doing virtual reality, most of the rendering is probably happening, on your device or on the computer that your headset is tethered to. But it's pretty clear that in the future that a lot of that compute will actually exist on a server, and it'll be pushing a lot of it down to the device, and the device might in fact be wireless. So there's a lot of predictions around where those workloads would go, where would they land, would they be on a server on the device edge, meaning in an on-premises data center, or on out in the field data center like in a farm, or would it be on the infrastructure edge, and that's divided up into the access sites, which are like where the cell towers are, the pre-aggregation sites where the central offices are, and then maybe the regional data centers like that Equinix primarily owns. And then of course you've got the rest of the cloud, and there's a really interesting fluid dynamic between that. But ultimately come up with this prediction for how much demand is going to be required to run all of these use cases over time. And that creates a forecast for how many servers you're going to need, basically. So how many CPUs, GPUs, and what's the power rating of those? And what I mean by that is what is the rated kilowatts that the server is capable of drawing. And the reason that power rating is so important is that those of us in the data center world, that's how we measure data center capacity. We measure it in kilowatts and megawatts. And so, there's this translation from, and this is how we get to the 800 billion. It's you build up the use cases, you predict the number of servers, the power rating for those servers, some prediction on energy conservation and so on, and you get megawatts, and you get lots of megawatts. And then there's a fairly straightforward translation from megawatts to the cost of the facilities and the infrastructure and the compute IT hardware that's needed to run that. And that's how the $800 billion number gets built up. We did both a very optimistic and a very pessimistic view of the growth, and then we split the difference, and that's that center line that is the prediction in the State of the Edge report. And at 2028, that is the IT power footprint is 65,000 approximately, 70,000 megawatts, and you do the math, and that's about $800 billion worth of infrastructure and IT gear to support that. So that's the business model, distributed across the world. Asia Pacific and Europe are predicted to have the largest footprint of this compute infrastructure. North America third, and then the Latin America and Middle East and Africa countries are predicted to be lagging relative in comparison to the others. And again, that's an assumption of the model. I'd like to see this more distributed over time, but this is what the model predicts. And then, as you can see, we broke it down into verticals, and there's a tremendous amount that's being used by the communication service providers. The mobile consumer continues to place a lot of demand on a lot of the applications that are predicted to drive server growth are from the mobile consumer. But as you can see, it's a pretty wide variety of industries, and all of those in concert create the demand for this $800 billion worth of infrastructure and IT. Okay. So let's talk about these individual sections. And as Jacob said, we can't cover the whole report. It's actually a pretty substantial document. But we pulled out some of the highlights, some of the things that are most interesting to us. So this is one person's opinion. These are the elements that we pulled out for the critical infrastructure. But what I think is most interesting about the critical infrastructure is, if you think of the internet, it sort of started in two places, May West and May East, right? And what connected those was what you can consider a backbone. And as the internet grew, that forked off like a tree into other locations. And so this backbone extended to what are now the tier one cities in the US. The tier one cities, there's 7 or 8 of them, and it's Los Angeles, Miami, Arlington, maybe Denver if you're generous. And what most people don't realize is it's really only in those places today that you can actually get on the internet backbone. What's also interesting is the internet backbone, when it originated, was provided by these large tier one transport providers, and so most of the traffic traveled over these almost monopolistic backbones. But two things have happened. One is interconnection and peering emerged, which means that the traffic didn't have to pass through the core. It could pass through a regional data center, through an interconnection point, which is sort of where the backbone ends, and be routed more efficiently and often less expensively, because a peering arrangement is usually a settlement-free exchange, which means one party and the other party agree that they're going to exchange about the same amount of traffic, and so they have these peering arrangements. So creating these new routes, sort of flattening the internet from this hierarchical structure in terms of way the data flows. The other thing that's interesting is all the really large hyperscalers have essentially built their own backbone. And nobody knows the exact number, but when we've talked to people who have information about this on good authority, the estimate is it's at least 70% and maybe as high as 85% of all of the internet traffic actually passes on private backbones owned by the Googles and Microsofts and Facebooks and so ons of the world. Now, what that means isn't the traffic that you and I as consumers use, but every time you initiate a Google search, for instance, it spawns out a bunch of workloads, a bunch of data gets passed back and forth, and so that number is sort of inclusive of all that. But I think most people don't realize that even though you see these beautiful images of these internet backbones, most of the traffic that produces what we call the internet today doesn't pass on those backbones. So what's happening as the demands for edge compute grow, this internet backbone needs to extend farther out to the edge. I mean, ideally, all the way out to the edge of the access network, so the cable head end or the cell tower, the baseband unit for the 5G network, or even actually down to the device or the premises. And so a lot of the underlying infrastructure that's enabling this vision of edge computing is coming from this critical infrastructure, which is a lot of fiber, a lot of modern optics that are lighting that fiber, a lot of software-defined network technology that's allowing for all of that, and a lot of the changes that are happening because the demands for edge compute are happening at machine speed. Meaning the biggest trend is we're going from a world of humans talking to machines, where we operate in ones of seconds, and the data coming primarily downstream, where we're consuming content that somebody else produced, to a world where it's mostly machines talking to machines. They're generating copious amounts of data, petabytes, zettabytes of data, 24/7, and it's happening at the edge, right? And in fact, again, the scale of the data really surprises people, but if you have a factory with a bunch of robotics on it, maybe it's generating a petabyte of data. It could take you an entire month to ship that amount of data over what we call the internet today. So it's creating this entire demand for an internet that reaches all the way out to the edge. And in fact, might even consider it being built from the edge in as opposed to the core out. Okay, so I'm going to go to the next slide because I could talk about this forever. Jacob, you want to cover?
You're in the right place. I love it because this IoT concept of generating data at the edge and trying to do stuff with it, right? That's value creation and interesting. So it's awesome to be surrounded, hopefully, by IoT innovators. Let's do hardware. Yeah. So a lot of this is, it's natural for people who are thinking from a cloud world out to think about hardware as servers, right? And things that look like servers. And yet I think it's an interesting point that, we're here at an IoT meetup where you can think about hardware in a very different way and think about the edge in, right? And that we're seeing both of them, right? We're seeing more purpose-built hardware. So whether it's like specialized, data center type hardware that is getting more and more efficient for specific functions, maybe trying to do inference from an AI perspective at the edge and trying to be cognizant of both the workload, but also the power footprint that Matt talked about. Power is more expensive, harder to get, more variable. Everything becomes a little bit more constrained as you move closer and closer to You could call it the edge, but you know where the thing or the people or the device is. And so that's an important part that we're seeing in the report, is that a lot more purpose-built infrastructure. You kind of can say building the software and the hardware together is a trend, right? Where possible. It's not always possible. We are at the same time seeing this sort of freedom of movement of open source software, which we'll get to later, and open hardware converging, where you have projects like the OCP, Open Compute Project, or Open 19, allowing for innovation at the hardware level from a data center perspective that is in line with the spirit of open source, right? And that says like, hey, let's take the costs essentially or the barriers of innovation down to zero where possible, right? So that we can add value in particular areas, like maybe a fancy new, software paradigm, or a hardware, creation, and that sort of delivery model of the hardware into the critical infrastructure that Matt talked about previously is becoming more important. That's one of the things that we noticed early on in this cycle, was that the supply chain and logistics, and putting stuff in places that we learned in the cloud kind of hyperscale model over the last, 10 years, doesn't just translate, to the edge, where things are constrained from a space perspective and a power, but also just people, right? You can't like just service these massive data centers. You have to think about lights out data centers, or small cabinets, or factory floors. And so that's a pretty interesting driver of innovation. I think we're still at the early part of that, from most people's perspective, especially on the sort of regional or edge data center side, where there's a lot of, kind of, you don't want to say chicken and the egg, but you have to kind of like see these deployments, really scale in order to get the supply chains and everything else in line with it.
Yeah.
You want to add to that, Matt? I was going
to add a couple things to that. So Jacob's absolutely right that is really almost a paradigm shift to operating edge data centers as opposed to centralized or core data centers, because operating 5,000 data centers or 500 data centers versus 50,000 data centers, it's a completely different animal, and oftentimes to repair something, you have to do a truck roll. You have to send a human out if there isn't some automated repair mechanism. So you need to have a completely different view of security, a completely different view of access, and a completely different view of servicing. So Open 19, one of the things that Jacob mentioned, Open 19 allows a fairly unskilled technician, meaning somebody who might be skilled in another trade, like climbing a tower or in marketing, can literally swap out a server or a router by sliding essentially a drawer into a rack. All the cables at the back blind meet, and it just, it's pull out, pull in, tighten a couple of screws. Anybody can do it. And so that allows you to use a different level of workforce to get that kind of the economy, the scales and the distribution. And it's a really interesting point that I think a lot of people overlook in the edge data centers.
Yeah, well, the tower industry is a great example of that. That's created a workforce around highly distributed infrastructure, and we're seeing that kind of start to evolve into the hardware. I think the IoT space is also just awesome. We highlighted at least one IoT specific hardware company out of the Hudson Valley that does, I forget their name right now. I'm going to blank on it. That has a more integrated approach, right? So it's delivering a sort of like stackable, this just goes here, put it where you need to go. The software, the hardware together, it just works kind of promise, which that kind of goes against some of the more disaggregated approaches we've seen in the cloud over the last few years, which is like, hey, hardware, software, just do whatever you want. They're separate. Put them together as you wish. We are seeing with the constraints of edge, some of the more kind of appliance-like or crafted hardware be useful and be deployed. Let's move on.
Yeah, and I think the other thing that occurs to me that isn't obvious to most people who haven't studied this is the power of the economics of shared infrastructure. So a couple things at the edge are different. One, it's more expensive to run and operate a facility. The second thing is there's just limited space. You simply don't have enough space, and so the ability to allow companies to share the costs, whether they're co-locating their servers in the same data center. Imagine if every telco and every cloud provider has to have their own edge data center in every possible location. There isn't enough fiber in the ground. There isn't enough land available. There isn't enough power. So we really do have to invent new business models around shared infrastructure. But the economics are just so profound. I mean, the ability to the vision of running a multi-tenant 5G packet core, for instance, and how that would share the resources and enable a much more highly distributed wireless infrastructure, especially as you're trying to go into less advanced countries or into rural areas. It's really profound. And so I think that's an important dynamic. And the hardware has to sort of adapt to those kinds of models, in terms of durability and power efficiency and so on.
As we move on to the next one, Molly, I was going to ask you to pop up for a second, because your company runs an edge delivery platform, an edge platform that doesn't build data centers and doesn't build. Which parts do you see as yours to add value to as a platform, an edge provider, and which ones do you not, that you just need someone else to handle?
Yeah. So basically, just for some context there, what we do is, what our platform does is try to abstract a lot of the complexities associated with distributing workloads across multi-cloud and edge infrastructure. So we don't own or operate any of the infrastructure or data centers ourselves, and rather we partner with everyone from hyperscalers down to companies like Equinix, bare metal, and so I think the role that we play is simplifying a lot of those complexities, while also providing the level of flexibility that engineering teams need to adapt their unique application needs.
Yeah, we're seeing all kinds of those kind of what you call it partnership ecosystems, right? Of different kinds of providers layering in to provide them that kind of end experience, which is like, okay, I have business rules, performance rules, cost rules, and I want to put them everywhere, as long as those rules are met. That's a software experience that you guys provide at Section, that's dependent on figuring out a lot of these other bits down the line, at least.
Yeah, and to that point, I mean, you mentioned cost and performance. There are so many trade-offs to consider, like, we're starting to see sustainability initiatives being incorporated into where you're deploying workload, and compliance certainly is a big one as well, with maintaining data in certain regional locations. And yeah, so those needs will continue to press on kind of some of the complexities, and folks like really being faced with the challenges of orchestrating workloads across all of those trade-offs.
Cool. Matt, do you want to hit networks real fast?
Yeah, I'll dive into networks. So as Jacob mentioned, a lot of the infrastructure that needs to be built at the edge is based on networking, and there's a number of technologies that come into that sphere. Some of it is the last mile access networks, and I think 5G is really interesting for a couple of reasons. One, it's going to enable a whole new range of wireless devices to do low latency compute, but also it is one of the first applications of edge computing. In the cellular industry, you used to go buy a box from an Ericsson or Nokia, and it was a black box. You couldn't do anything in it. But if you were to actually open up the side panel, there's an Intel server in there. And the virtualization of network functions, I'm oversimplifying quite a bit, but the idea is you're taking what would normally be running on a black box baseband unit or some other piece of appliance like hardware, and virtualizing it into software so you can run it on a white box server, maybe with some enhanced components, FPGAs and other sorts of technology. But you actually could run it on a server using cloud native capabilities. And so what that allows you to do is it changes the economics of it. It allows those servers to not just run the network itself, but to run other kinds of workloads in a multi-tenant capacity. The other thing is it does, and I don't know if you guys saw the news today, but Dish announced that they've selected Amazon to provide the hardware to run their network. And so if you think about the economics of rolling out a nationwide wireless cellular 5G system, it's a lot of money to spend. And if you do it all yourself, if you're trenching all the fiber and putting all paying for all the servers and all, that's quite a bit of money. And so the idea that you could get somebody else like Amazon to pay for the servers and then you lease them as a service fundamentally changes the economics and I think the velocity of the rollout of a lot of these capabilities. So 5G is really hitting an inflection point. A lot of the capabilities that will follow, because the infrastructure is being built out to support that, will support a lot of really interesting edge computing workloads. As I mentioned earlier, there's new types of interconnection and peering emerging at the edge. Again, data wants to take the shortest path it possibly can, because that's what reduces latency. It also reduces cost. And so if you can have two networks, if I'm on my cell phone and Jacob's standing next to me and he's on his cell phone and I send a WhatsApp message to him, it's probably going to travel a few thousand miles round trip, and I'm being generous, before it gets to him. Now, it won't matter to us because we're operating in ones of seconds, but to a machine that's glacial. And so you really have to do a lot of this path reduction. You might hear the term local breakout. That simply means that as soon as the data comes off the tower or off the cable head end, it gets broken out into the local market where it can then be peered with other networks. So in a future state, if I send a WhatsApp message, rather than being backhauled to Los Angeles before it actually even gets an IP address or whatever city the telephone network goes to, it would be broken out locally, be given turn into an IP packet that can then be routed and peered with an alternative network in that local market. And this will fundamentally change the traffic flows for not just IoT devices, but all of us during COVID with with a lot of kids at home doing remote learning, just reduce all that data path and keep a lot of it local. And then finally, the last thing is the emergence of unlicensed spectrum, and it's CBRS is probably the most obvious, which is this again it's shared infrastructure. I don't have to go and own $1 billion worth of spectrum licenses in order to deliver some wireless services. And then, as I mentioned earlier, projects like TIP, the Technology Infrastructure Project, which I think its most interesting thing come out of it is a project called Magma, which is a modern packet core, which just sort of runs the cellular network. That's an open source project, and it's also multi-tenant. So not only can you run Dish's packet core on Amazon servers, but you potentially could run multiple providers' packet cores on a single set of servers. And so again, this just tremendously changes the economics of building and operating networks, as well as the technology and the enablement that those networks provide.
So it's funny because you can't talk about any one of these sections without talking all the rest of them. Like hardware, software, networks, they all go together.
They certainly do.
The software aspect is probably, especially with our home at LF Edge now, the most it's one of the biggest trends of the last 20 years has been just the evolution of software, and how many software you could call them developers, but software minded people there are in the world. Really just loved I just finished Jeff Lawson's book, Ask Your Developer. It was a great read. You should totally read it. It really speaks to a mindset, and I think that idea that Matt talked about of machines talking to machines is epitomized with the kinds of software we're seeing. So big trends there. Nothing surprising if you live and work in Seattle, but that distributing applications and running workloads in more places is getting easier, right? Some of it due to open source software like Kubernetes, and then the services that build on top of that are on other systems like Section, right? They're doing that for you with software experiences. So orchestration, big driver here. 4 years ago when we did our first report, it was really hard to think about, how many companies or people could disrupt, markets by saying, what, I want to put this software experience or this workload in hundreds of places. How many companies had done it? I mean, like 10, 15 maybe. and in the world. And now you can see that capability, especially with shared infrastructure, going to many, many more, where instead of, hey, I'm diverse because I'm in US East and US West, now we're talking about like, yeah, I can put that in, as many places as I can orchestrate it to that I want to afford. And that's a really big change. So serverless, certainly really interesting at the edge, and sort of other smaller footprint, ways to kind of like, deal with what we're seeing from use cases. Is not just sort of like big applications that are like, attention grabbing, like, self-driving cars, right? Really complex, very interesting, very integrated, but there's a lot of other stuff, especially in the IoT world and in, the consumer world, retail, where much more, chunked up experiences, right? Little bits of activity, moving you through your, day, your advertising, your movement, all this kind of stuff. And so we're seeing some smaller footprint, um, functions as a service, be used at the edge. And then this one is kind of going in the opposite direction, but that idea of hyperconverged, which Matt just talked about, the networks being disaggregated from that. We're seeing, especially in hard to reach location, that's still really important. So the name I was forgetting before is HiveCell. We talked about them in the hardware thing, but they're combining hardware and software to create basically a very tiny, hyperconverged solution. So marketplaces was the one that I don't think is mentioned on this little part here, but came out in the report, and that's where we're seeing clouds bring their marketplaces out. Right? So especially the hyperscale clouds like a Google with Anthos, and Microsoft has one as well, and we can see Amazon with Outposts and other kinds of things pushing their ecosystem, which is sort of like the way a lot of people think about the internet is what happens in the cloud. And so moving that out further is definitely happening at the software level.
Yeah, and I want to add to that. When Molly was describing some of the interesting uses of section, something that occurred to me is we're moving to a world where workloads are placed and run in a highly automated fashion, and they're also based on intent. And what I mean by that is you package up a workload. You can't have a human saying, "Oh, I need you to run this workload on this server," right? It just because things are happening too fast and it's too complex. But you can package up a workload and say, "Okay, I need this to run in this region, and it can't leave this region because of data sovereignty. And I need it to have this kind of SLA with the network slice, so a certain level of latency and reliability. And I want to run it on a certain carbon footprint." Right, and at a certain cost. And you have these orchestration systems and scheduling systems that are actually starting to ingest a lot of the real-time data, matching that up with intent, and then placing a workload, placing thousands of workloads simultaneously in very, very sophisticated ways. I don't know, you want to add to that, Molly, at all?
No, you're spot on. I mean, just the pairing of machine learning with that and predictive placement of those workloads and adapting on the fly. It's all coming together.
Really interesting area of work. Okay, well, I think we're mostly at the end. We're going to cover the landscape, so don't head off early. But the State of the Edge report is available at stateoftheedge.com. You can download all the reports historically, the 2018, the Data at the Edge report, the 2020, which is where the model is covered in its entirety, and then the 2021 report, which we covered today at stateoftheedge.com. And Molly, you want to talk about the ecosystem and the landscape that describes it?
Yes, thank you. So at the beginning, I forget if it was Matt or Jacob who were describing some of the work that goes on within the State of the Edge project, and one of those being the landscape. And for those of you familiar with CNCF, I'm sure you've come across their landscape, which is extremely expansive, but has become a go-to tool for the cloud native ecosystem. So similar to that, we've built out this interactive ecosystem tool within LF Edge. You can see the URL to access it there, where we've developed the category structure across, or made an attempt to develop the category structure across the entire edge ecosystem, which, as you've heard, among all of the different components contained within the report, is rather diverse and expansive on its own. So that was our first challenge a year ago when we came together as a group, this working group, to really try to come up with a categorization that made sense and was inclusive of all of the diverse components within the ecosystem. So this is kind of the first iteration of that. And we're always looking to build on it. And so it does become that go-to tool that's similarly used within CNCF. So I would invite everyone to visit it. And if your project or company that you represent is not currently on there, we would be happy to add a listing in the category that makes sense for you. And I believe on the next slide, we have some instructions. So we said we're not a code-based group here, but the landscape actually is. So, if you're familiar with Git workflows, it's a simple process of opening a PR to submit a new entry. Or if you're not comfortable with that, we have an option to just email your listing to us there as well, and we can get it added for you. But like I said, we're always looking for more inclusion, so always welcoming new members as well.
Right, and so you don't need to be a member of LF Edge to have your project or company listed, right?
You do not. Thank you for that clarification. You do not. We want it to be as inclusive as possible so that we can make it the most powerful tool we can.
All right. Well, we should wrap, and I guess we could take questions if there are questions. This is how to reach everybody, and the project and all of that. And if you'd like to make the deck available, I can provide a PDF. I don't know if this group has a place to host those things, but I certainly would be willing to do that. And I can stick around for a little bit and answer questions.
The questions that you popped in here, should we tackle a couple?
Yeah, thank you guys. That was awesome. Obviously, I had a lot of questions. There's still more, but I'll save those for some other time. Thank you. This is really good. Yeah. So I had a question on the model, the 800 billion. Is the raw data available with the assumptions?
So it's not. Part of the reason we as a little nonprofit were able to get access to the sophisticated model is Phil gets to own the model, but he ran the report for us.
Okay.
But he's very friendly. So yeah, but he's been building versions of this model for years. Yeah. And yeah, he just did a special cut at this for the State of the Edge.
So we need to make friends with Phil.
Yeah, you just need to, just stalk Phil. That's I would.
Okay. All right. Yeah, because my interest there is actually on the verticals, because I've been looking at productivity data across industries and looking at where are the opportunities to improve labor, capital, type of productivity.
Well, I encourage you to reach out to Phil because he really does love geeking out on this stuff. So if he's got somebody who's can make a research contribution or a critique or add some data, I think he'd really like talking to you about it.
Awesome. I will. Folks, if you have questions and you want to come on stage, raise your hand or ask it in the question thing. Otherwise, I'll carry on with my own questions. So I think, Matt, you had mentioned on the edge, new business models are evolving. What are some of the examples that you're seeing?
Well, I think one of the most profound is the one that I mentioned that was in the news today, which is a wireless company running its infrastructure on someone else's hardware in someone else's facilities, using someone else's towers, and for all I know, someone else's radios.
Yes.
It's absolutely profound. Yeah. And then I think when we start getting into sort of multi-tenant architectures, that's going to be a really interesting shift in the business model. So I think that a lot of the CapEx, OpEx shift around shared infrastructure is really, really interesting. And in terms of like other business models, it's kind of the Wild West a little bit. Yeah. I mean, because if you look at the trend, most of the things that are happening at scale in edge computing today are actually infrastructure, right? There aren't a lot of end user applications running on the infrastructure yet. It's infrastructure. And that's why I think like 5G is so interesting, because it's creating a tremendous amount of demand for the fiber and the data centers and the servers. And that's going to create the wave that's going to push all the other applications to the edge.
Yeah.
I'd love to hear, Molly, what you see,
Yeah, actually, you probably have the most experience.
I had a couple to add to that, which I think there's also existing businesses that are, becoming more digital. You think about McDonald's buying, sort of like, drive-through technology businesses. Makes a lot of sense, right? So retail and consumer experiences. And one that I learned about after this report kind of shipped, but I thought was really fascinating. It's right outside of Seattle in a rural part, which is a blockchain-based, build your own community network business, like called Althea, which I thought it was fascinating, around like, okay, attacking the sort of underpinnings of the network in a totally different way than the dish one that Matt's talking about. It was very, very, very distributed and solving these little niches within, the gaps within our infrastructure, but with a business. So I think there's really cool stuff happening, especially the further out you go, where it's the technology, hardware and software is now actually accessible in many ways to build infrastructure.
Yeah.
And I think additionally, more so on the software side of things, as is true kind of across the entire technology landscape, more as a service models that are being chained together. So I know that one major challenge with distributed computing is how do you solve the database challenge? And that's one that we're trying to actively address with database as a service providers and chaining that together with various other as a service offerings.
Yeah, so you have networks as a service, a network slice, a piece of database, a piece of compute. Yeah, that's absolutely true. Yeah. One of the other things I want to mention is maybe thought about is that the next wave that I see coming, macro wave, is really driven a lot by COVID. My kind of flippant way of saying it is every company that had a 10-year automation strategy now has a 3-year automation strategy. And that's really true. A lot of the conversations I've been having have been about how do we automate what we're doing to reduce costs, but also to prevent the sort of disruption that we saw with COVID.
Yeah, no, and that applies all the way down to small manufacturers as well. We've been working with a number of the local manufacturing trade associations, which is, I think people on the meetup have heard me throw out this statistic before. 98% of manufacturers in the US have 500 employees or less, and 75% have 20 or less. And all of these guys, a lot of this tech is way beyond them, but all of them, in fact, one of the groups here has just started a whole new series trying to figure out what all of this means for their small manufacturers, for their members. So yeah, it'll be interesting, and all because of COVID. Before they weren't interested, now all of a sudden everyone wants to know, what it's going to bring. Okay, so I had another question. You guys have been involved with this for a while. So what have you seen since you first did the report to today? Like, what are some of the big changes? And I guess I would add to that, if you had to predict what 2022 report will say, what would you like it to say? Or what do you think it will say?
Well, things are moving faster than I think we thought. So, I mean, we are obviously in the business of edge and edge computing. So there's been a lot of optimism, especially in early reports. But what's changed is like the seriousness in the application. I mean, COVID being a massive driver, like Matt said, but just in general, the idea of end user experiences being high value. And you can see that in the kinds of businesses that are, blossoming on the stock market and, whatever else is this digital world. And so that's like up and to the right. And edge computing with that name or other names, right? When you can drive value, new value, that's not just like, hey, reduce my cost, which is important. I do this thing, I want it to happen cheaper. And we're moving to this kind of like more like, and the edge is really more about opportunity, and that's that's accelerating, and I think faster than I thought. When we first did the report three or 3.5 years ago.
Oh, cool.
I'm not going to predict 2022. I can't think about it.
Well, hopefully it will be truly past COVID by then.
I think one of the most interesting changes, and I was trying to think of one that isn't obvious and wasn't obvious to me, I think, until really recently. So I think we've always said the edge is like bigger than any one company, and we're going to have a lot of collaboration. But I'm seeing levels of collaboration in the industry that are unprecedented. I mean, you hear Molly talking about chaining these services together. I mean, you're seeing hardware companies chaining their hardware together. It's really amazing how it's accelerating it. It's a very exciting time to be in this industry.
Yeah, no, that's I totally agree. And you can't do it alone, right? It's no vertical stack. Well, you're doing everything yourself. Yeah, it's a lot of this is new for everyone. Cool.
We didn't even talk about Starlink the whole night. That's crazy. No satellites.
Yeah, that's a whole different edge.
Not yet.
2022.
Exactly.
Or Mars.
Yeah.
That's right.
Elon will have his edge servers up in the sky, literally. It looks like a question came in here. So Randall Newton. I am writing a magazine article on edge and cloud for product engineers. Today I heard a new to me phrase, data gravity. It sounds like a centralization, but if IoT edge is anything, it is decentralized. Anybody want to comment? Matt, you're smiling.
Well, so data gravity is really interesting. So for those who don't know, the concept of data gravity is that gravity data behaves like physics. There are laws that apply to it. There's a whole study around this, but in general, the data is. I mean, I mentioned a petabyte of data could take a month to ship over the internet. So imagine that's a gravity. That's like the gravity of the sun. And what it does is it pulls the applications to it. And so even though it does sound centralized, you can also think of it as if you have a factory that generates a petabyte of data, it could take me a month to ship that data back to Seattle. It could take a fraction of a second to ship the application to the data. And so in terms of edge computing, I think that's why data gravity is so relevant. I mean, there's a lot more to talk about that, but that's the one takeaway I would leave with people.
Yeah.
Matt, can I ask you a question? I had a question about your announcement with VMware and everyone else.
Yeah. So Jacob is referring to our announcement a couple days ago, or last week actually, on what we call the Open Grid Alliance, and it was led by my company Vapor.io and VMware, along with 4 other companies: Packet Fabric, DriveNets, Mobile Edge X, and oh my God, I'm going to forget the
It's been a long week. Come on.
It's been a long day. It's a long day.
Okay, we're going to look it up.
But you go to opengridalliance.org to read about it. There's a manifesto. We're going to be shipping a white paper. And so the way to think about it is there is no one edge, right? And that you really need to be able to access the edge everywhere as a common set of resources. And the kind of the fancy word for it is fungible, the fungible edge, right? Which has nothing to do with non-fungible tokens, but at least people know what that word means now. And really what that's saying is, again, it gets down to this intent-based intent-based way of saying is that you need to be able to specify a workload in terms of what kind of networking capabilities it needs, what kind of resilience it needs, what kind of cost it can support, what kind of, what generation of silicon it needs, what special capabilities. And then you need an automated system to be able to deploy that. And when you think about how that has to be built, it cannot be built by any one company, because there are people that trench the fiber, and there are people that build the data centers, and there are people that put the servers in the data centers, and the people that write the middleware, and the people that write the application support tools. And then there's the applications that actually come online. And so there's the only way to accelerate that work is to bring a bunch of organizations together. And so the Open Grid Alliance is attempting to do that. It's very early days. And I think what's really interesting, it's not a standards organization. It's a new kind of organization. It's a go-to-market ecosystem.
Awesome.
So the members, part of the criteria for joining, and we haven't published it yet, but we are going to allow lots of other people to join, is you're bringing a technology and you're integrating it into this ecosystem of other technology to support this. And then that group of companies is attracting applications that take advantage of it.
Mhm.
And the first application for this is, you probably guess, is a multi-tenant packet core. But there's a lot of really interesting things going around that, and a lot of the other applications will come on top of it. So that's what it is in general. But there's a webinar you can sign up for where you can get two of the technologists who will talk about it in more detail. We're going to publish a white paper. A lot more is going to be coming down the line, but it's a pretty exciting project.
The the one that you forgot is named after a guy, and his first name is Michael, and his last name is Dell.
Oh, that little company.
Oh my gosh, I forgot the 800-pound gorilla. Yes. No. Yeah, I'm gonna get in trouble for that.
They're gonna kick you out of Texas.
Yeah.
That's funny.
Thank you, Jacob.
It's interesting. You say that it's a go-to-market alliance because one of the things, if you start working with OT groups, they don't have resources to do all this integration, to build all the apps, right? They don't have DevOps, they don't have any of that, and they don't want it either. I was working on a project a couple of years ago with a solar manufacturer with their operations and maintenance group that has their own OT group, and those guys went and picked a 1995 solution only because the vendor, who was literally from the 1990s, could drop it into the data center. They didn't need to touch anything, and it came up. And they rejected all the IoT platforms because it required people to develop stuff. And they were like, we don't have it. Right? The field engineer, when you're going for budget, the field engineer always wins over the tech guy in OT.
Yeah, and I think that's really what all of us need to do. And I think the industry is recognizing, as I said, a really fundamentally different way than I've ever seen operate, where we just have to lower the barriers to building rich and interesting applications. It has to be DevOps friendly. It has to be ubiquitous. And that's a really interesting challenge. And a lot of companies are going to have to agree to work together to make it happen.
Yeah. If anyone's interested, I put up an article on LinkedIn last year around this, the IT/OT wars, based on my experience. Some gray hairs, but that's awesome. We're coming up to 5:30. I would first off thank you very much. This was really cool. I had scanned through the report. This actually helped bring it together. And now I'm going to go back and read, and I'll connect with Phil. Also, it'd be great to have you guys come out individually to talk about what your companies are doing.
Sure.
I'll send you a little. That's what I was trying to do earlier. Share a deck that kind of goes into the types of topics we cover, but I'll send that out separately. And it'd be great to have you guys come and talk about your stuff too. Otherwise, I think that's it for the questions. Folks, thank you very much. When I end this session, it will take you back into the lounge. I will be hanging around until about 6 at the IoT table, at the meetup table. If you have any questions about the meetup, we're always looking for speakers and volunteers. And if you're interested, come and find me there. I don't know if Matt, Molly, or Jacob, if you have time, but you're welcome to hang out for a bit in the lounge as well. Otherwise, I want to thank you for your time today and for sharing about the report and the landscape. The landscape is cool. I'll go check that out. Thank you.
Thanks for having us, Hans.
Yes, thank you for having us. This was really a lot of fun.